Welcome. In this video I'm going to show you how you can obtain the Wilcoxon signed rank distribution using R. I'm using Jupyter Notebook, but all of this should also work in, for example, RStudio. In this video will simply focus on how to obtain this distribution by using the recursive function. I have a separate video where I explain a little bit more about the concept, where I go basically over the introduction. I also have ways to actually use simply my own library, which has a function to immediately calculate it. I have a separate video on if you want to do it by enumeration, but in this video I'm going to use the recursive method. So the frequencies can be obtained for the Wilcoxon signed rank distribution by using this formula. It simply states that if x of these two is less than 0, then it's 0. It's also 0 if it's greater than this binomial coefficient. It's 1 if y equals 1 and x is either 0 or 1. And in all other cases, and that's where the recursive bit comes in, we use a slightly different formula, and that's this one. Where, as you can see, this simply refers back to itself. This binomial coefficient can actually also be calculated simply if it's 2 by simply doing the sample size times n plus 1. So that's actually this y plus 1 should have been n plus 1. And we can have a simple function that actually does all of this. So it starts by looking at if x is less than 0. So that's in this case, then it should return 0. The other one is if x is greater than this one, which is the same as I mentioned earlier as this one. So then if that's the case, then it should return a 0. If y equals 1 and x equals 0, or, and this is an indication of or, these two bars, is 1, then it should have returned a 1. And in all other cases, what it does is its own function, and then x minus y, as indicated here, comma y minus 1, comma y minus 1, plus, and then x and y minus 1, x and y minus 1. So we can now simply use this created function, and let's check with an example. We use as a sample size, let's use 6. I don't think I specified it earlier, so n equals 6. And we have a sum of ranks of 3. And then we can simply use that and calculate everything. Sum rank not found. Of course, I should the sum rank frequency. That should be SRF. SRF, this was actually from a previous one. I should just use only SRF. So that gives me 2. So there are only 2 possible ways to have a sum of ranks of 3 if n equals 6. Now the probability mass function, the probability of this is fairly straightforward. That would just be dividing this found frequency by the total of all frequencies, which will be the same as 2 to the power of n. So we can then simply see that in this case the probability of having a sum of ranks of 3 if the sample size is 6 is just about 3%. So this 2 gives me that there are 2 different ways to get a sum of ranks of 3 if you have 6 items. So for example, the possible ways of obtaining this would be, let's think about this. If it's the first one is a 1 and the second one is a 2, that gives me 3. Or the first one is 0 and the second one is a 3, is a 3, so that also gives me 3, and I think that's about it. So that's only 2 different ways. For the cumulative one, we then simply add up all of them that are less than our n, so, or our t, so 0 to t, and we can then simply see that that should return to us, in this case, the 7.8%. So it's a 7.8% of obtaining a sum of ranks of 3 if the sample size is 6. Alright, I hope this video was helpful, and thank you for watching.